I will hit this fancy go live button. And just get everything set up over here. Okay, I think we're good to go. Welcome everybody to our sustainability and engineering design for the environment. See Wonder kind of live learning at home workshop. Really glad that everybody could show up today, and let's jump into it. So there's me. I'm Nathan, your engineering outreach program instructor. I am a software engineering student who is going into my third year, so I'm halfway done, and really happy to be here, and I'm really happy that you guys could show up, and I will allow my colleague to introduce himself.
Hi everyone, my name is Nicole. I'm also going to be a program instructor for live learning at home, but I'm also the engineering outreach coordinator for Ontario Tech University. I graduated in 2018 with an undergraduate degree in biomedical engineering, and I also did my master's in industrial engineering, which we'll talk about a bit in this lecture. But great to see you all today.
So yeah, Nicole is a very, very cool guy. If you have any questions, we'd be happy to field them. And yeah, let's start talking a little bit about the code of conduct. As we know in regular classroom, online classroom, we expect kind of the same thing. Please respect everyone in the virtual classroom. That is one of the key points. There you can see it at the bottom. Just being nice and respectful. I'm sure we probably won't have problems with that, but I just have to state it anyways. Joining the Zoom session with your first and last name is really important, so we know who's coming in and coming out. Microphones and cameras must remain off or on mute for your safety and privacy. And the chat function should be only used to talk about the activity during the session. Keeping it relevant, making comments, asking questions, totally fine. Just keeping it relevant and on topic. Awesome. And here are some of the controls at the bottom of the screen if you are not so comfortable or not so familiar with Zoom, right? Keeping your microphone and camera off unless you need to ask a question. We will ask you and be like, yes, you may turn your microphone on if you feel comfortable. Here's our quick disclaimer about live learning sessions being recorded. These are going to be made publicly available on our YouTube channel afterwards, so people can review or they can see it for the first time there. And there may be a chance that you will be recorded, so if you don't want that to happen, no need to turn on your camera or your microphone. And just remember that the consent to be filmed was completed during the registration process. And let's begin our sort of introduction slides about STEM and what we think this is. We've probably heard this word before, STEM, right? It's kind of an acronym for science, technology, engineering, math, and it's what we use to kind of understand the world. Science, one of those understanding and applying things through experiments to kind of help us understand the world. Technology, we build these tools and machines that help us work with engineering and STEM and science. And engineering kind of uses those tools and uses a little bit of mathematics to solve real world issues, right? And mathematics is the numbers and the building blocks and how we can get into STEM. So we've definitely heard that word before. Hopefully we can apply it soon. That E in STEM is engineering, and we are obviously engineering outreach. So we are kind of the engineers, and engineers are kind of like the problem solvers of society. We invent, design, build, test, analyze, and we use these machines and systems and structures to solve problems. Okay. Does anybody know any types of engineering, or have heard of any cool ones, or if you even remember the ones that me and Nicole mentioned at the beginning? Let us know really quickly if you've heard of any. The chat is not recorded. Computer engineering. Awesome. Yeah. We'll talk a little bit about computer engineering hopefully soon. Civil engineering. Yeah. If you know anybody that is studying or works in one of those fields, very cool fields, computer engineering and civil engineering. Welcome to everybody that's just hopping in right now. We haven't gotten too far into this. So I study software engineering, and yeah, we'll look a little bit at these types of engineerings, hopefully throughout these sessions. We've got mechanical and electrical on the bottom right there, some of the huge fields, some of the biggest ones. And then there's aerospace, which works in this sort of like free air and sometimes space travel. And then we've got like mechatronics, who kind of combine computer, software, mechanical, and electrical to build mostly like robots and stuff like that. Computer engineering, working a lot on like hardware and stuff like that. Biomedical, building things like prosthetics, really cool. Nicole might be able to tell you a little bit about that. Chemical engineering and civil engineering, awesome fields. There's, I think, if I remember correctly, like over 40 like different fields of engineering, and they're all like super useful. I just thought that was a really cool fact. Yeah. So we've maybe heard about the engineering design process, but if you are not familiar with it, it's the way that engineers kind of approach problems in order to kind of solve them. And we've got some very crucial steps in that sort of process. So the first one, obviously, being identifying what your problem is, and making sure that you have a clear grasp of what the problem is before you attempt to tackle it. And then what you want to do is brainstorm your ideas to try to solve that problem, and just spitballing, coming up with as many as possible, and then hopefully selecting the right ones. And then you design a solution with the ideas that you brainstormed after you've identified your problem. And then you make a model of your solution, and maybe even a model of your problem. And then you test and evaluate. And the engineering design process is kind of like a cycle, right? You can go back to any of those steps once you've hit that sort of endpoint and you realize, okay, so maybe my model wasn't the greatest design of the solution, or maybe my solution wasn't the best, or maybe even you didn't understand the problem fully in the beginning, and it's totally fine to go back all the way to that first step and kind of reiterate through this design process. And that's what's so great about the engineering design processes, is that you have the opportunity to go back and work it out. And if you follow these steps, right, you should be able to crush any problem that comes your way. Obviously, today we're talking about sustainability, and we've heard this word. Hopefully, recently we've had this kind of like uptake in the sort of like idea of sustainability. And what this is it's the process or actions in which humans avoid the depletion of natural resources to keep an ecological balance that doesn't allow quality of life for modern societies to decrease. And I think we've got a neat video to show that hopefully talks a little bit about sustainability. I actually had a problem with this audio before, so it's okay if we don't need to play this video. Essentially what it's saying is, right, we haven't been here for too long as humans, but we've made sort of like lasting damages to the earth. And even if we were to stop immediately, right, it would still carry on forward. We have to be more conscious about what we're doing to the environment and how it's affecting us and affecting sort of the natural ecosystems that we have on Earth. So sustainability is all about making sure that we have enough for the future, and that we are still meeting our needs today. And we've had these 3 pillars of sustainability that you may not have heard of. We talk about society, environment, and economy, and you may have heard them as the 3 Ps: people, planet, and profit. And our goal is to make sure that society can still stay, can still sort of maintain that quality of life, and the environment will no longer suffer, hopefully, and that we can still make decent profits from our actions and not have to sacrifice too much. And this is kind of what companies are hopefully beginning to integrate into their sort of models, looking forward to the future. Okay. Sustainable design is a little bit about what we're talking about today, and our goal is to kind of design for the environment. And that sort of wheel on the right there is how we should think about things when we begin to design, and we should take every single one of those precautions to make sure that we protect the environment as we design products. This sort of life cycle analysis follows the entire product. So we can begin at this sort of materials extraction phase, where we kind of get raw materials from the earth, and then we take those raw materials, manufacture them into goods. Those goods get distributed to retailers or directly to your house. And then begins that sort of usage phase where, you wear your t-shirt, you use your cell phone, and then the end of life management reaches however long it takes. And then we can break that sort of down into the way that we get into that, the way that it sort of ends its life as a product. Hopefully, the most preferred way is to reuse that product, right? So a broken cell phone or a sewn t-shirt or something like that, or we can recycle, turn it into something better, or compost it. Energy recovery, something like biomass fuel from like banana peels or organic compost. And then least preferred, go to a landfill. We'll go into kind of each of those segments of that life cycle. So the first one we saw was material extraction. So that's kind of relating to the energy it took to extract, grow, or transport the raw materials. And the way that we can kind of stop or minimize the effect on the environment is with a couple ways that we have listed at the bottom, these examples. We can avoid using toxic materials to the earth. We can avoid materials with a high energy content. And we can use materials which are renewable, recyclable, and or recycled. So these are things like glass and whatnot. If you see that like maybe a glass bottle that you're purchasing is recycled, it's a pretty good sign that you're kind of taking that effort to make sure you are supporting sustainable design, right? So there's no point in recycling all your glass bottles if you're not going to use glass bottles, right? So just making sure that you do your part in terms of what you purchase and stuff like that. So that's the materials extraction phase. We can talk about that sort of production phase where we have like an example of making like a t-shirt where you need to spin and weave and then dye textiles for like the shirt that you wear, or maybe the jeans or whatnot. So minimizing of the use of toxic materials, like in the last step, minimizing energy intensive steps, and also minimize and reuse and recycle residues and waste from production processes. So we can kind of think about these things if we are maybe starting a business or whatnot, making sure our production phase is as sustainable as possible. Right. Move on from the production phase to the distribution phase. So getting that product out into the world and into the hands of consumers. And that relates to the energy required to transport the finished goods from production sites to retailers. So what we can do here in this step is optimize efficiency, transport modes, maximize work with local suppliers and markets. We can have a sort of standard transport packaging, maximize the use of refillable and reusable containers, which is huge, and avoid non-eco-friendly packaging materials. Maybe we've seen a rise, if you've ever had sort of packages sent to your house in biodegradable containers. And I don't think the city accepts these, the city of Toronto, but I think you can still be using them in your garden if you have one, and sort of decomposing them that way naturally. And it's great compost for your tomatoes if you're growing something like that. So that distribution phase, definitely key part, just like everything else. The usage phase relates to the energy and emissions during normal product life. And this includes the maintenance and product reuse. So examples, washing, drying, and ironing purchase clothing. Something like a fan you purchase, right, for your room. Minimizing that sort of energy consumption is kind of a great way to keep a sustainable design in terms of usage. There's no need to keep your fan running 24/7 when you can crack open a window for certain parts of the day, right? So just minimizing your energy consumption, like turning off your fan if you don't need it. Maximize product reliability and durability. So maybe checking out reviews for products that you buy, right? How long is this going to last you? Is this like there's this kind of rise in the idea of fast fashion, right? Currently, buying products that are really cheap and don't last you very long. Let me just double check. Okay, buying products that are really cheap and they don't last you very long, and then you throw them away and you go ahead and you buy another one, right? So we should kind of be ecologically conscious when we're purchasing things and thinking to ourselves, how long is this going to last me? Am I going to throw this out after maybe like a week or so? And could I have maybe bought like a used one instead? Minimizing the amount of used consumables. So that is talking about usage. And end of life management. This is kind of bigger than it seems, right? This relates the energy used to dispose the product, either through reuse, recycling, incineration, or landfill disposal. Might be bigger than it seems, right? Because when you're done with something, you just toss it in the trash and you kind of get rid of it. Has anybody ever heard of the term wish cycling? Yes, no, wish cycling. A yes or a no in the chat, if you have or have not. Nope. Is that a general consensus from everybody? We're seeing no. Okay. So this is kind of the, maybe you've done this before and it's okay, right? It's just sort of like this idea where you take something that you know is not recyclable or compostable, and you kind of just like hope that it will be recycled. I know it's kind of a crazy idea to hear, but it happens a lot, where something like plastic straws, right? You know they're not, or maybe you don't know. I wouldn't consider it wish cycling then, but maybe you don't know that they're not recyclable, and you put them in the recycling anyways, and you kind of just hope that maybe they'll find a way to recycle them, or you just kind of hope that it will be recycled on its way there. But sometimes what happens is when you put it in the recycling, it kind of contaminates the rest of the recycling, and sort of like that bin has to be tossed away, or you put a bottle of water or like a half-filled bottle of water into paper recycling, or like a can of Coke into paper recycling, and then it ruins the entire bin, and that whole thing gets sent to the landfill instead of being recycled as it could have been. So that's kind of the idea of wish cycling, making sure that we keep our recycling for recycling. Stimulate possible product reuse, right? So making sure that we're using our products as they're intended to be, and kind of keeping them as live as long as possible. Stimulate possible remanufacturing or refurbishing, right? So accepting used products, if you're a corporate business or something like that, selling things, accepting used products and refurbishing them and selling them back to consumers that don't really care for buying new products or want to do their part ecologically. Stimulate possible recycling of parts and materials, right? So maybe breaking down used goods to kind of salvage pieces of them, like the glass from a cell phone screen, or the gold inside the circuits, or something like that. So yeah, technological waste is pretty huge, actually, and a lot of it gets sent out of the country, and we don't really worry about it when it still affects us, just maybe not today. So the life cycle analysis is all about evaluating the inputs and outputs for every stage of a product or process or service, from cradle to grave, right? From its sort of inception, or right, straight from the raw material sort of gathering to the way it gets kind of broken down. And this kind of allows us to calculate the environmental impact throughout the entire life cycle. We can identify quantitatively ways to improve the product or process. And we can compare and analyze different products or processes and kind of see, is one company being more ecologically conscious than another? Is this product maybe a better alternative to another product? And where we should kind of put our money and kind of stuff like that. So the goal and scope is to define what we want to analyze and how deep the analysis will be. We can do this inventory analysis where we determine the inputs and outputs of a product's energy and materials. Or impact assessment, we can evaluate the environmental impact from inventory analysis. And the interpretation, we make reliable conclusions and recommendations. Design metrics are how we can tell if a design is sustainable. And a metric is kind of like a quantitative or a qualitative assessment to compare and track performance or production. And the way we can do that is by using a couple different metrics. One is the process, the productivity and processing time, right? So how efficient is that sort of process and how long does it take? The quality, right? Maybe buying a stronger pair of jeans instead of like a cheap one that maybe you'll throw out in a couple of months instead of a couple of years. The financial cost, benefit, and rate of return is another design metric. The social sort of metric where we can gauge the satisfaction and usability of a product. The environmental kind of design metric is the fuel source and emissions of how we kind of made that product and delivered that product. And the governance, which is regulations on the product quality. Got a couple more. We can think about the product life cycles and the resources going in and out, like the greenhouse gas emissions, carbon and other greenhouse gases that are used in the process of getting it out and creating the product. The water usage, the amount of source water taken and the use. The chemical usage, amount, impact, and type of chemicals used, right? So hopefully using non-toxic chemicals, but kind of being conscious when we don't. The labor practice, policies to support the worker, right? And waste disposal and energy usage. Waste disposal is the amount, impact, and type of waste generated and how it's disposed. So maybe like toxic waste, we should be very conscious when designing products that produce toxic waste. And energy usage, the amount, impact, and type of energy used. So maybe something, the difference between like a CFL bulb and an LED bulb, where an LED bulb is much more energy efficient than something like a CFL bulb. But in different scenarios, you may need different bulbs. So if we are okay for time, we can jump into our kind of like activity for today. So let's start off in the first stage with identifying our problem. And your mission is to design a sustainable mask to curb the spread of COVID-19. Okay, so we're going to, maybe you saw the email before the lesson today, but our goal is to kind of design a mask sustainably. So let's brainstorm some ideas. Let's think about the type of face masks that are available on the market now. Or if you want to come up with your own design, feel free. It might be a little bit hard. And then what is the purpose of each and how effective might they be? Can we try to perform a simple life cycle assessment for each, right? And we've got some examples on the right there of the types of face masks that are on the market right now. The standard sort of surgical face mask that you'll see, the N95 face mask, which is sort of like a step up from the surgical face mask in terms of protection. The cloth face mask, which looks a little bit nicer, and the respirator for large and small particulates. So we'll give it a second if you guys want to think about what kind of face mask that you might want to design. And you may have probably that's a great idea, Kalina. Kalina suggested to make a cloth face mask and put something like a coffee filter inside to kind of filter out germs and bacteria in the air. It's a great idea, Kalina. I'm going to go to the next screen, which might show supplies you'll need to kind of make your face mask. What I'll be using is some old fabric, like this kind of rag I have. I've got a second one for 2 layers. And I've got some string to use that I got from the recycling. We were about to throw away a bag I noticed today, and I just kind of pulled these strings out of the shopping bag. And they make a really good mask shield. And I've got my scissors to cut my cloth and some tape to hold it all together. So yeah, great idea. Nicole talked about how great it is to kind of add additional filters to a cloth to improve the sort of effectiveness in virus defenses, spreading the virus, which is, as yeah, I didn't even notice Nicole talked about how that is a important design metric that we talked about, which is kind of huge. Okay. So the purpose of each mask, we kind of spoke a little bit about that. And a simple life cycle assessment for each might be sort of like the cotton to make this dish towel. Not sure if it is, or if it's some sort of like polyester or something, is kind of, so yeah, there is some polyester. So maybe some oil from a field was taken and then refined. Sorry, I got a little bit distracted. I noticed my camera's might go out soon, so I might need to swap the battery. And then, so the cotton also got refined and then spun and woven. And then it was used to create this. And then this kind of got packaged and sent out to maybe like a home hardware store, or just like a home sort of like purchasing store. I'm not sure what they're called. And then we bought it, and then we used it for a pretty decent amount of time. And then now it's kind of reaching the end of its life. It's almost died on us. What I was thinking actually was using one of these, right? But this one is still very, very new. I had this in my sort of materials box, and the sustainability of buying this and then immediately turning it into a face mask was not as appealing as using something that I've already used before and is kind of nearing the end of its life, especially with this one here. So I made the sustainable decision and chose to use the old one. So Nicole asked a great question, not only as an engineer, but also as a user. What might be important in a face mask in design and use? What might be important when you think about it being eco-friendly? So if you want to answer those questions in the chat, feel free. So I kind of performed my simple life cycle assessment on my product. If any of you would like to share your life cycle assessment on the products you're using, I'd love to hear it, but it is not totally necessary. So here's another slide about kind of designing our solution. We'll think about the product life cycle and the resources going in and out, identify our metrics. When will a face mask be worn? What regulations are placed? How will the face mask be worn? Does anybody want to try answering Nicole's questions or the questions that we've got listed here? You know, when will your mask be worn? What regulations are in place for masks, right? Does it, are there types of materials that we can't use for masks? Or is it kind of like anything that covers your face goes? And how will the face mask be worn? Now I'm going to quickly look for another battery. My camera really quick. Anybody? Okay. Nishtika gives us a great answer here. A reusable mask seems important for it to be eco-friendly. So that way you don't just, so you don't throw away a mask after one use. Okay. So having like a washable mask or something that you can maybe replace the filter on, like one of these that I've got. And it has this sort of like removable filter pouch on the inside that I use. And Nicole makes a great point. As engineers, we have to consider all of these metrics, but we definitely have to identify what do we value the most and prioritize in our products. Yeah. So maybe what Nicole is hinting at that I'd like to mention is I don't think most of the time there are regulations on the types of masks that we use in Toronto. As long as something is covering your nose, mouth, and chin, you're okay, right? But something like a single piece of tissue, you know, if you sneeze, right, that tissue's gonna get basically destroyed, right? And it's not gonna provide great coverage after that, or even before that, I guess, right? So even though the regulations say that as long as it's covering your nose, mouth, and chin, you're okay, right? We have to kind of think about our own sort of design metrics and what we care about. Okay. Anybody else want to answer these questions? I can move on to the slide that kind of shows us how we would create our masks. And quickly, I'm just going to replace my camera battery. I'm still here. Hopefully it won't take more than a couple seconds. I'm back. So I'm going to quickly look at this really quick. The types of fabrics, what kind of protection they provide. So one layer of a tea towel is, one layer of a tea towel is about like 83% effective when covering your face to filter out particulate. 69%, 20, 68, 61, 58. So even as a double layer, the tea towel provides the most protection. So if you've got one of those old ones, awesome. But still with 70, 60%, you might be okay. And make sure you consider the resources going in and out. Let's make our model of our face mask. So what we need to do is we need to measure out 10 inches by 6 inches on the fabric that you use. I'm using sort of dish rag, which might be a little bit thick, but it's okay. And I'll take my ruler and measure out 10 inches on one end And I wish I could tilt my camera down and show you while I'm doing it. So I'm just measuring out. Ten by 6. No, this horizontal line. So I've drawn out. It might be a little bit hard to see this on camera, but I drew out the square I need to cut, starting from this corner over to down here. So I'll just lay my other dish rag underneath that, or I'll cut those separately because it might be a little bit hard to cut with my scissors. And I'm going to go ahead. Cut out 10 inches that way. And then cut out I got one part of my face mask, which might be a little bit big, and my cut's a little bit lopsided. But yeah, what materials are you guys using if you are following along? Anybody using a tea towel? I know that was the highest highest protection rating. Anybody using like an old t-shirt or something? Kitchen cloth. Awesome. Ishika. Okay, I'm almost done cutting this out. And oh, Colleen, you're using a handkerchief. Awesome. Okay. And what I want to say was Nicole pointed out something really awesome about making models and prototypes and whatnot. These are huge in engineering, right? Making models and sort of doing things so that we can understand, right, how something will work, like a proof of concept, or something like a full-blown like scale model that's just been like scaled down. Now I've got my 2 segments of cloth for my 2 layers. And what I'll do now is I'll lay these on top of each other. And then I'll fold this the top, about 1/4 of an inch is what they say. But as long as it's in that sort of secured position, it's okay. I'm just going to take some tape to hold it down. I got my edges folded in and taped. And then I will fold the edges in, kind of like that. And they say to thread your string in or elastic after you've kind of folded them in, but if you want to lay it down now and then fold it in, might work better. Okay, and then at this point, once you've folded in your sides, tuck in the string. I put the string in just before I folded it, so it kind of looks like this. Then I'll tie my string up. Just with a simple knot. And then tuck the knot inside. The same with this side. And there we go. I've got my bit oversized mask that is more of a model than a functioning and fully fleshed out sort of product. A little bit big, but it's okay. Anybody finish theirs? Or are we getting close? Great points. Okay. So I've made my model, and if you are still working on yours, that's totally fine. But once you kind of reach that end phase where you think you're done, it's time to test and sort of evaluate. How are we doing? Nishika Kolina? You guys okay? Almost done. Okay, awesome. Anybody else almost there? And we can ask our questions. Awesome, Kalina. Let it sit for a second. I'll give it like 1 more minute. And I'm going to go back to those metrics because our first question is which metrics are important. And the reason we ask that is because we can't address every single issue at once for everyone. But let's take a look at those metrics again. Okay, we're almost at that 1 minute. So does anybody want to give me a sort of guess at which, or maybe not even a guess, which design metrics are important to you? If you were to be designing a face mask for everyone to use. Oh, awesome, Nishika. Okay. Don't feel pressured. It's okay. Does anybody want to say what design metrics are important to them right now? For if they were to be designing and producing a face mask to sell. I can. So maybe if you're designing something with like a sort of like artistic design, or you're to put some like nice colors or something, maybe the social satisfaction, right, is really important to you as a design metric, right? Making sure that people receive the product well and like using the product. You got an answer from Colina. Financial is one of them because we would have to make a lot of them and we shouldn't waste too much money. Yeah. So great answer. We do want to make a lot of them. Shouldn't waste too much money. We should also think about how we are going to be making these masks, what materials, environmentally conscious materials, hopefully. But yeah, financial, definitely huge. Don't want to be spending more money than you're making on your product. Quality from Nishtika. Quality is one of them for me, since that would increase durability and that's better for the environment. Okay, yeah, for sure. So if you're making sort of face masks out of used materials or clean but sort of like discarded cloths and stuff like that, yeah, you could definitely think about the quality and how you can make sure that it lasts the longest. And maybe you want to think about greenhouse gas emissions if you're going to go with something that you need to refine, like from oil, if you're making like a polyester mask or something like that. And let's think about this sort of like challenge question. What tools, devices, and procedures could engineers use to test out functionality? Great thoughts. Thank you, Nicole. That's awesome. So even without like the face mask right now, let's say you wanted to, for an example, test out the aerodynamics of a car. Where would you take that sort of design and to test it out? Does anybody know? So if I'm, let's say, forward and I've come up with this new super, I don't know, truck, or the new e-truck that they're thinking of or something, right? Where would they take that sort of body of that truck to test out like the aerodynamics and the drag and whatnot? And I'll give the answer if we don't know, but we're accepting any answers. It's this sort of tunnel. I know somebody's got it. If you want to take a guess, that's totally fine. It's a it's a wind tunnel. You would take it to like a wind tunnel or something like that, and then you could test out like the aerodynamics, or maybe you could take it to like a track to test out like the functionality or something like that. So maybe even to test out the durability of this face mask, the face mask that you designed. Maybe you could stress test it, right? In a sort of like vice grip, or something that can read off the force that's being applied to it, right? And seeing, is this suitable for everyday use, right? The number of newtons that I'm going to apply when putting this mask on my face every day, right? I could test that out and exceed it, right, in a sort of laboratory, in a sort of controlled space over and over and over again. So I could test out like the functionality or the quality of it, right? McCall talks very highly about quality, right? Very important. So did our design work? Did anybody's design not work? Or does anybody's design fail? It's totally fine. Or is fail is like a relative term. So I would say my design failed. It's too big. There's a bunch of tape on my face, which is not comfortable. And really the only thing good about it, I'd say, are sort of the strings that I found like this morning for this, right? That's probably the best part about this. And even them, they're a little bit too large, right? I should shorten them, right? But I would say that maybe this failed, but it's totally fine because we can make changes. Yours is too big as well. Yeah. So maybe I gave us the wrong dimensions, but it's fine because, right, this is the engineering design process, and it's not just a single line that takes you straight to the answer. It's a cycle, and you can come back and revisit all those steps and make it better than it was before. So some of the changes I'd make is I'd go back to designing a solution, and I'd maybe give dimensions on the string, right? The string length, I'd shorten that. And then I'd change the binding material I used. From, instead of tape, I'd use glue, or I'd use, I think I have some thread with me, or I'd sew it together instead of taping it together, which doesn't feel good on my face. Okay. Anybody have any questions? Or try to make it adjustable. Awesome solution, Nicole. Yeah, try to make it adjustable. And if maybe you didn't make a face mask, does anybody have a question about like the face mask or something? My question would be, what would happen if I were to have used something like a tea towel, right? Would these folds become thinner and therefore less bulky, and the mask could maybe fit in my pocket or something? Because right now, if I fold it up, it's not going to fit in my pocket, or it's going to be very awkward to fit in my pocket. Could I have tried a different design, right? Instead of it going around my ears, could I have tried one that kind of has the loops on the bottom and then goes like over my head, like sort of this one here, this mask that I usually wear, right? This one goes over my head like that, and then this one goes over my head first and then kind of straps to the back of your head like that. Would that be more comfortable or less comfortable? And that's pretty much it. Anybody have any experience they want to share about their face mask? Or if not, we are about 5 minutes close to being done. We can continue on. And kind of wrap it up here. We're almost at our, where's my time? Almost at our 5 o'clock mark. So if anybody has any questions about what we learned today, Nicole asks, or any questions about engineering in general, or something like that, we'd love to hear them. I can stop the stream.